Hi everyone, welcome to the second part of the Serpano assembly stream. Today on the last stream we soldered part of the front here with the USB Type-C, with PD, with power delivery in. This is really dark, but that's here. And then also the DC jack and the first part of the power path, which is the DC boost, which boosts whatever power we put in to 15 volts. So then we can DC buck it down to whatever voltages we need. Still no elevator music now. I thought there was some music when the standby screen is going. Or did you mean during the whole stream? But yeah, well, let's give a few minutes just for everyone to maybe get the notification and join. Although YouTube's notifications have been pretty bad recently, I don't know. The hell are they doing? Yeah, but just get in there. Yeah, hi Gerald, hi Adam, hi Rotter, hi Colin, hi Henrik. Almost missed it, but you didn't. Outside noises, you can probably hear that, sorry. What does that mean, Adam? I'm not sure. Interesting. I'm looking, we have 8 people now. Last time we had 30, so I wonder what happened. It's the same time. Maybe the notifications, yeah, failed. But yeah, while we wait, I can have a quick overview of the schematic again. Let me switch here. Oh. There we go, that works. I'm not sure how much you can see. Wordplay, yeah. Not sure how much you can read of this, but maybe it doesn't matter the exact details, just the overview. Right, so on the first page here we have a very basic, like a very standard CircuitPython setup here. We have the SAMD51 LCD, QSPI flash, and a NeoPixel. And then here we have the headers. Hi Brian, thanks for joining. Then on the second page here, this is the 3 times DC buck, which is exactly what we will be working on today. So yeah, it's one chip that we put in it 15 volt, and then we get 3.3, which supplies the SAMD and pretty much all the chips that are on the board. Then we have a 5 volt, which is for the battery charging. And then the third one is adjustable voltage, which we use a digital potentiometer here to control the voltage that we adjust. And then also we have the current sensing here. And here on the last page is pretty much what we did on the previous stream, which is here we have the USB connector with the power delivery, the DC in, and here's the battery connector and the battery charging, which we will skip for now because that's low prio. Then we have a fuse, switch, and the DC boost. So pretty much all of this is done already. What's the LCD? The LCD is the 1.3 inch 240 by 240 SPI display, which is like pretty popular right now. It's the same that's on the Adafruit Clue, and that's pretty much it. But I've seen it being used more and more because like you get really good resolution and it's SPI. So Seems to be quite popular. So this schematic, I use KiCad for designing my schematics and PCBs. So this is a printout from KiCad. I just have 3 sheets. You can see here. So these 2 sheets are actually here as symbols. So I have output from them, and then this connects them to the rest, to the main sheet. Yeah, it's a ST7789, yep. I have not looked that much at the FUSB 302, but I know there's a product on Tindy with this, it's a breakout board pretty much for this chip, and there is some Arduino code for it, so that's a good starting point, but from what I've seen, it didn't seem that bad, so. Oh, hi Deshipu. Yeah, now I can show this one again, since now we have the other camera, which maybe chooses to focus. There you go. That's probably a lot better than the other one, because this one is at least full HD. The other one is just HD ready. There we go. So we have the USB, the tiny PD. What if we do this? All the battery stuff is here, which, yeah, we skip for now. There's a reset button and a NeoPixel. We will need a reset button later, because just to reset the SAMD, because I will use the UF2 bootloader. And then here, yeah, the DC jack, which I tested off stream. It works, no problem. I can switch. I can have both, and then I have the diode, the protection diode, so it seems to work, no problem. Hi, Grogard. And yeah, I have the latching switch, so which I soldered backwards, so it actually, when it's up, it's on. That's silly of me, because I even marked it on the silk, so that's I done goofed up. And then yeah, here we have the DC boost, and the focus is killing me right now. And I have lots of test points all around, just because, yeah, I wasn't sure how well this is gonna work. So far, we got the 15 volt on the 15 volt test point, so that's great. And yeah, this is what we will be doing today. Pretty much most of this area. This is the triple DC buck. Lots of stuff around that. Here we have the current sensing with a current sensing resistor, and this is the I2C pot, the digital potentiometer. And from what I've seen, it should be possible, from what I read, to first solder, to not have to solder everything here. So we can solder the chip and solder most of the passives here just to get it running, but then we can skip the digital potentiometer at least first when we test the other 2 voltages. If I just because the way this is done is there's an enable pin for each of the voltages, and by default the adjustable is off. So I think even if, yeah, it should just work without that, or we will see smoke, so we'll see how that goes. Hi Mark. Hi Bolly. Yeah, I see we're 13. I think I explained most, so we can get going. And I remembered, I think I forgot to open my interactive bomb, or maybe I have it on the other screen here. Yeah, okay. I can drag it to my screen. There we go, because today we will actually be assembling it a bit better in regard of the order, because it was a bit annoying last time, because I had to do it in a specific order of the components on the board, so I had to shuffle through like 30 packages of components just to find what I need. But now we will take a bag, find it in the BOM, and solder it. I already separated the components that we will solder today, so it's only this many. So it should go faster. Shouldn't be wasting time on shuffling components. Maybe. We'll see how that goes. Right. So let's get the soldering action on. Actually, I want it that way around. And all right, there we go. I still have to get used to the making sure that what I see, like you see what I'm seeing. So the part is in the middle because my view is larger than what is in the camera. But we will, of course, start with the, oh, that's actually the wrong one. This one with the DC chip. Maybe, let me just flip this again. Yep. Oh, that explains it, why it was so dark. So I will need the hot air because we start with the chip. I think, where did I put that? Actually, do it. There we go. I think I will crank up the temperature today and see if it melts and explodes, because last time it took so long. What could possibly go wrong? So, too many things connected here. So before I started, prepare everything. Actually, I need a TS100 today. Can I fit there? Okay, that actually works. Which tip do I have? Good enough. I don't know, what do you see here? Not much, so let's switch back to this one. And currently I'm using only a 12 volt power supply for the TS100 because the 24 volt one I got with it, the cable is kind of short and very thick, so I wasn't really like enjoying it. So I switched to the 12 volts, so it takes longer, but at least this cable is way nicer to use. So I'm okay with it taking slightly longer. Yeah, exactly, Brian. You got something for that? Because I have a lot of Type-C chargers, but where did I put the chip? It was just here. It was just here. Okay. I put it on top, and then when I moved the box, it fell inside. Oh, Mark, nice. Bring up new board. You have to fix USB. What's wrong with it? Did you flip data pins, or is it just you have to solder it and test? That's a lot of IOs. back. Okay, this will require a lot of heat. See how that goes. Right, the chip is here. Okay, let's go for 400, which is pretty crazy, but I also don't know how, sorry about that, but how accurate this actually is. I'm gonna move the microphone a bit away because I know it's really annoying. Okay, that didn't go so badly, but I actually cranked it up. It was taking too long, so I cranked it to 440, which is insane, but clearly that worked, and it didn't melt just yet. So let's see if it actually reflowed properly. Yeah, it's stuck there. Nothing seemed to fall out. Seems good. Hi Dren, hi Keaton. So now we flux it and we drag it. As you can see, since this is high current situation, like this chip actually, like I said, it's a triple buck, and it has two outputs that can do 2 amps, and then the third one can do 3 amps. So you can see the traces are maybe now you can see the traces are as beefy as I could make them based on the reference design. So not sure if anyone will use 3 amps, but right, I think I have the wrong tip here. Might be a bit too thick. Let's try with this tip and we'll see how that goes. Nope, I need to change it. Finally that one turned off. Yeah, so right now this is let's see. This is the B2 tip, and I'm gonna switch to the, okay, is it the I tip, I believe? This is a TS100, in case it wasn't clear, in case someone is curious. Just gonna move some stuff around here, remove this tip. It is hot. Put in the new one. And cure it. Just reading the chat. Fusion 360, it is free indeed. Yeah, it's quite nice with KiCad that it exports step files, so you can import that in whatever is your tool of choice. I use also Fusion, but I'm not against the other tools. That did not do much. There we go. Why are these first two so uncooperative? There we go. I can see it's a bit skewed, but that should not matter really. I love when a good drag solder works. Yeah, Brian, I couldn't imagine soldering anything, well, not anything, but SMD without a microscope, because, I mean, you can see the benefits immediately. And this is also why I upgraded from the previous, the digital one, because it was, yeah, it was just not good enough. Like, the benefit of a stereo microscope cannot be overstated. Like you see in, in 3D, which is awesome. You can see the depth, which was something that is gonna be lots of heat here. Yeah, you can see the depth as you're working, which is, I got so used to that. Yeah, the LGA chips which don't have the pins on the bottom are, yeah, I mean, you wouldn't be able to solder it like this. You would have to use a stencil or try with hot air, but that's very, yeah, you can't really trust that. Oh, this have to squeeze more and more in there. There's one, so the other shouldn't be far because it's even thinner. There we go. Yeah, seriously, I couldn't imagine soldering this without a microscope. Just you get so used to this. Maybe a bit more flux wherever I put it. Right. I use it under my vise to angle the chip. Yeah, I don't know how official the name like the LGA is, but I've seen it used quite a lot. So that seems to be, it's pretty much a BGA, except it doesn't have the balls, and usually the pads are square. But I gotta say, I'm quite happy with the TS100. Can't complain. The tips, the variety of tips you can get for it is good. Like I have the 3 basic ones which I always use, and that's pretty much all I need. Come on. Well, now I screwed it up. Nothing a bit Flux can't fix. So overexposed, which is not great for you watching. Hi Martin, what am I soldering? That is what I'm soldering is in the name of the stream, and there's a link in the description for Hackaday, which has some bit more info with renders and some photos. But basically what it is, it's a breadboard, dev board, and power supply in one. You can also check out my Twitter. The pinned tweet on my Twitter, which is the link is in the description, has more info on this project also. Yeah, thanks, Adam. All right. I'm really happy with this one. It looks terrible because of the flux, but that's what alcohol is for. So what we do now is, the way I do it at least, is I tin one pad of each of the footprints. So then I just put in chips, parts quickly. Since we got this one, I guess we will solder it on the left side. It is decided. Yeah, so these parts are mostly 0603, which is quite nice because, at least in KiCad, the standard tools, the standard footprints, 0603 is the last one where there's actual silk, like outlining the orientation here. So in 0402, I don't think you get those. So with this, oh, you can. With these 4 pads here, I wouldn't know if the chip goes like this or like this. Here I can see the silk. Yeah, I think you can see those. No. So I could have gone 0402, but also 0402 start to get annoying hand soldering. 0603 is not a problem. Yeah, so this is the boring part, tinning all the pads. Right. And yeah, I use too much, definitely. Maybe I should add a bit more juice to this. Yeah. Yeah, I add too much, but it's not really a problem. I can wick it later if needed. Or I can just do like this. Yeah, soldering stuff where the power planes are big is quite annoying. Oh, that's gonna be a nice one to solder. I mean, this is something you don't really think about when you design the boards. Like you can see this whole row here. these four are vertical, but these four are horizontal, 2 and 2 here. And if you're hand assembling, it does matter because, yeah, you don't want to solder something across here. But when you design it in KiCad, it's not something you're, or when you design whatever tool you use, it's not something you're really considering. And when you're pick and placing, then it also doesn't matter as much. But for hand assembly, let's then, just for fun, then we can claim we started work on the display. There you go. All right, so everything, oh, not everything, my bad. Maybe less talking, more working, or maybe should focus. Okay, that is everything. There's a 5-volt test point. There's the Vcon, which we haven't tested, but nothing smoked, so we assume it's okay. I don't remember where I put the rest of the test points, but I have them in the BOM also, so it's not a problem. So what's happening in the chat? It's actually run away from me. I have to scroll back up. Right, a microscope, yeah, it's a good, it is a godsend. Yeah, I think the link for my microscope, an affiliate link, is in the description also. If someone wants to buy, I can definitely recommend it. I've been using it for a bit now and I have no complaints. Like, yeah, it's a proper, like, I don't know how you call it, analog with all the lenses and so on. And yeah, I mean, there's no, the way I'm looking through the eyepieces, there's no digital components, so there's, you can't really comment on the quality. It looks great, and the camera, that's a separate thing, but it's a full HD camera. I think it's pretty good. Maybe the exposure, I could actually, I could get distracted. I have a remote here. Actually, I'm not sure this remote was working. Oh, this menu is super confusing. That's really, I don't, if I'm going left and right and it's not changing. Wait, what? When it's manual, I cannot change it. When it's auto, I can change it. Okay, then. Someone let me know on the stream, like, what value looks good. Because I think this looks better now. Like, it's less exposed, but it's also getting darker. So maybe it's too dark. Yeah, we are at 4 now. It was 14 when we started. Less yak yak. Okay, then. I thought that was the point of the stream, to also talk, no? Yep. Okay, I'm caught up with the chat. So what we do now is, like I said, I take apart, I find it in the BOM, and we place it. And that's one of the parts that I don't need actually right now, at least. Wow, did I sort this? Right, this is for the current sensing, so that one I wanted to skip for now. A little brighter, we can do that. Maybe something like this. You see the focus is also a bit maybe like this. Right, 10 UF. 603, you can't really see my bomb. So we have 3 of these. C35, which was here. Right, I should flip this board. Since I tinned all the left side. Maybe that wasn't so wise. Maybe I was talking too much because my my soldering iron went to sleep, so I talked it to. I bored it to sleep. What I'm gonna do is I'm also gonna flip the board in the bomb preview 180 way. And this way I notice I soldered this chip wrong. This should have been a 10 nano, not 10U, 10 micro. Green I have here is about can I boost it? I think the microphone is actually max because I have to. Oops. My mic stand got a little sad. Let me mute and fix that. Sorry about that. It fell off right on the metal base, which, yeah, that's not great. Emergency repairs. Okay, I'm not sure this is gonna stay there, so I think I'm gonna have to keep the microphone down, but then I have to boost it probably. I can try to do that. I don't know, is this better? Let's see, is that doing anything? Yeah, that should be, I think, boosting it. Let me know how that sounds. if it sounds any better. Probably all the other sounds will be also a bit louder. Yeah. So the problem with the microphone is I had screws going into 3D printed plastic and they just fell out. So I need to put inserts, proper inserts in there. Yeah, there's your splat. What was I even doing? Okay, so we have the 46 resistor. Where does that go? Okay. Right. Actually, I'm not sure which screen is showing. Right. There we go. Just double checking that the values are correct, because that's not gonna go well if they're not. Then we have the two inductors. Here and here. Yeah, I'm still trying to figure out, proper streaming techniques. And yeah, since you say less talking, more working, that makes me think. Should I talk as I work? Because, I mean, isn't it boring if I not talk and just solder? That's not interesting. Right. Then we have 22 pico, which is, there's a RC circuit here that, or let me go back. There is a resistor that controls the frequency of the DC-DC, and then there's a fine-tuning circuit, RC circuit, that makes sure that the frequency is kept, and this is part of that one. And that goes to C29. Is here. And yeah, I forgot to buy 0603 ones, so I'm using 0402. It's quite a lot smaller, but it works. Oh. Hmm. 28. And then one more. C27, that's surgical. Right here. This monitor I have here is proving a bit too small because I cannot see at the same time. Oh, and the menu is on the screen. Why did no one mention that? Sorry. Yes, my YouTube streaming says the current bitrate is lower than recommended. Yeah. I think there's still sound, no? Right. Then we have 47 nano, which is part of the DC circuit, the inductor and capacitor. And that is C38. Right here. It's quite a lot of components, but it shouldn't take that long, hopefully. We'll see how it goes. C39. Right. C40, which I see is right here. What else is happening in the chat? The chat got a bit quiet. Let me know what you're working on. Is the sound coming through? Because nothing is... Okay, yeah. I wasn't sure. The message from the YouTube streaming was strange and nothing was happening in the chat. I wasn't sure if the audio was going through. But we got an answer, so we're good. Cool. I'm glad to hear. So if you're familiar with DC-DC circuits, you'll know there are many strange valued resistors in those, because the way it works, there is a feedback circuit, and the feedback is just connected to a reference voltage. So you have to create a voltage divider to get the voltage that you want. And to do that, you will probably use 1% resistors, which come with funky values. And this, like the one I just saw there, that's a 73.2K resistors. That's something you would often use. Yeah, but one of those were 0402 here, but the rest I have proper value, proper size. I mean, it's not a problem. It would have been worse if it was the other way around, if I had too big. But smaller is all right. And the next value is 2.37K. This project was actually quite unusual because it required me to do a lot of calculations to get the values of the resistors, and mostly resistors, and some caps and the inductor. So for the DC circuitry, there was a lot of formulas I had to calculate to get the voltage that I wanted, the frequency that I wanted, the ripple, and so on and so on. That was quite interesting. How accurate did I design the voltages? Well, let me show you with the microscope, because that seems to work quite well. Maybe not as well, because that's all you can see. But so here, this is the adjustable buck. Here's the feedback, and there is a basic divider here, but you also have the digital pot, which has a basic resistance and then there's it's a 50K in 256 steps pot. And here you have very lengthy math. So when the pot is 0, you will get 12.1 volt, and the idea is to be able to get 12 volt. So there is some wiggle room there. And then at full resistance, 50K, you get 1.654 volt, and the idea was to have it 1.8. So yeah, there is some wiggle room, because this pot, I think it was like 5% tolerance even on the digital pot. So there will be some stuff happening here. My idea is to also, since I have the current sensing circuit here, it also measures voltage. So hopefully I can create a bit of a PID here where the current sensing chip measures the voltage, and then if it's not exactly on point, I will adjust the digital pot, and that way it becomes perfect. I don't know how well that will work. We'll see. Hi, Dustin. Yeah, exactly. When the load changes, the voltage will also drop a bit. So hopefully we can have a circuitry that compensates for that. Yeah, I have no idea how fast it will be. This is all somewhat new to me, so we will see. This is, yeah, as I mentioned before in the first stream, this is a prototype board, so it's not the final way. I just want to test proof of concept. The next resistor, 82K, not as funky as it would seem, but still a very specific value. And it goes right here. I need my TS100 to heat up for a moment. Good. All right. This is a pretty big ground plane, or a power plane, so it needs some extra juice. There we go. And now we have an UF cap, but a bit more beefy ones. Right. I mean, some voltage drop is expected. I don't know, like I mentioned, this bug can do 3 amps, but I don't think anyone will use, I mean, it should be possible to use 3 amps, I'm hoping, with all the design. But I don't know how many people will actually use 3 amps on it. 12 volts at 3 amps. That's a lot of power. I guess people can use it to drive motors if needed or something like that. But I'm guessing most use cases will be under 500 amps, unless someone wants to drive strings and strings of LEDs. And hopefully that should be possible. What I did actually is, I can show that in a moment when I solder these two. Again, these are way closer than I would have liked them to be, but in 3D preview, you don't feel the distance as much. It's quite alright. Brian would use 3 amps. What I wanted to show is, again, I'm using the microscope as a third camera. I bought this. Okay, that's too big to fit in the camera here. I got this board here from eBay. What it does, it's DC load. So you just adjust the potentiometer here, and it can take quite a few amps through this chip. Oh yeah, it's just a MOSFET. It's a TIP tip 122, and then there's a big heatsink with the fan. So it just tries to keep it cool as it's sinking all that power. And then I want to try this together with current. I guess I don't need the current sensing because that will be on the board. So I just want to check how it behaves on different loads. And I think this is a very cheap way to try to test that without having a proper bench DC load. So we'll see how that goes. And we're back. I think it's a lot better now that I lowered the exposure. It's not as bright, blindingly bright. Oh, actually, I was wrong. There's one more 0402 I have to use, and it's a 2.2. It's also part of that RC circuit for stabilizing the frequency. So we take 3 of these. Let this be a teaching moment. Do not repeat my stupid mistakes. What I did here is I set a to-do, calculate these values, and I just left it TBD. But that means now in my BOM, all of these are TBD, so they're grouped. So it's hard to find them in the BOM because there's a big group of just TBD that's all around the board. So yeah, once you have your values, you should update them and regenerate your BOM because it just feels like a waste of time now. So it's C24. I think it's here. Yeah. I think I lost my 2 cups because I put the paper and they're gone. There's one. I have more, so that's not a problem, but that was silly. Okay, so that goes here. Thanks, Colin. I don't know what it helps with. Does it help with the algorithm or something? I'm not as versed in YouTube. So there they are, 042. Now I need to find the other two. This was C24. Now we have to find C25. Hopefully it's not too far. Okay, there it is. I did it a bit. Hi, Mr. Who. You're a bit late, 1 hour late, but it's not so bad. Still soldering, not much tested just yet. I put the label for this one here, these two, which when it's upside down is a bit confusing. We have 24, 25. Where is 26? Why is it so hard to find? I do have a noise gate. Is it too high? Am I being cut off? I can lower it. Since I'm further from the mic, I can understand. Okay. Yeah, let's see. Okay, if it's... Okay, that still seems to cut off the background noise, but then I think this is as low as I can go. Hi, Eddie. No, it's a workout is good. You shouldn't sacrifice that. Okay, there it is. There it is. C26 right here. RTX voice stuff, I have not. I thought RTX was some new NVIDIA graphic enhancement stuff. Is it also for voice? Okay, that takes care of this. And then we have 10K, that's always nice. Where's 10K? So this 110K is more important than the other 10Ks because it's a 1%. One percent 10K. Because it's also part of a feedback circuit. Interesting, Colin. And then we have a 43.2K. That might be all the resistors. Special resistors, I think. Yep. There's a 45.3K also. There we go. And that goes here. Okay. That actually concludes all the special resistors. If I see this. So now we have the big inductors, but I think that one we will put last because that one I'm fairly sure will require hot air. But maybe let's have a look at it first. Actually, I don't need hot air for this one, so we can do it now. There it is. It has nice pads on the side, so we can solder that. And I marked it. Oh, actually, I just need one because this is only for the adjustment ones. Right. I already, yeah, the other inductors are already here. It's only this one. Because this one is more expected to give more current. that should do it. And as you can see, we have still quite a few components here, and that's because these I didn't have them in my bags because they have to be common values. So for that, I just go to the bomb and then I click the position, and the bomb will tell me what goes here. Like this is 10 nano. So for that, I have my trusty box. And I see in the bomb that there's 3 of these, but actually I don't think we will place all 3, because I thought maybe some of them go for CircuitPython also, or the SAMD, but nope, all 3 are part of the DC circuit, and that is here and here. Yep. Then whatever goes here, let's find out. This is one more that's TBD, and I'm fairly sure this is a 20K, because that's the R part of the RC circuit. What is the marking? R17. Yep, that's a 20K. And for this, I have my trusty resistor booklet. That was R17, then it's also R19 and 21. Here's 21. And there's 19. That takes care of that. So what else is missing? All of this here, that's probably like 10K just pull-ups or something. And these two U9, this is the pod. We could skip that for now. Yep. So what do we have here? Okay, that's a 10K. tweezers getting magnetized or sticky from flux, who knows which one it is. And there's another one right here. Then all these, yep, that will conclude this part. Yeah, most of these are 10K. That's a few resistors. I don't have anything on me to demagnetize them. I don't know, there are tools for that allow you to magnetize and demagnetize, like, yeah, screwdrivers and so on, but I don't have one. Maybe it would be a good idea to buy one. Might also be flax, to be honest, I'm not sure. Not that bad, like, as long as it releases eventually. Worst case, you can also just you wait for the solder to cool and then it will stay in place. Three more, let's see. These are also marked TBD. And I think I know what these are. Yeah, these are also pull-ups. I just wasn't sure about the strength. But these are 100K. So yeah, I'm really happy about these containers. They seem to open without a problem. Nothing is spilling out when I open, which was a bit of a concern. That seems to work fine. So we have the last one. It's a cap. One UF. No problem. And then we solder the other side of everything and we can actually see if we see any smoke. If not, now the fun part. I think I have to, once I solder before we power, I have to quickly go through the schematic again, just so we know actually what to expect, which values where, so we can test that stuff works. I know there should be some voltages, but the adjustable voltage, for example, like I mentioned, is off by default, so that one should just be off. So if it's missing, it's not an error. All right, I think that's all of them. Oh. To be honest, this one doesn't matter because it doesn't connect to anything here. There's no pot there just yet. All right, there we go. We could actually have a quick clean test so it looks more photogenic. I have a few Q-tips here. Oh. Too many to see. And then some alcohol, IPA. I know this is not the best solution because it doesn't really remove the flux, it just kind of moves it around while dissolving it, but the residue is still there. We do have a ultrasonic cleaner in the hackerspace, and that works miracles. It's super clean after using that one. But it's good enough. You can at least see the label here. So when the smoke goes off, you will see. All right. Will this work? It is. It's a bit too little. So let's switch. That's still a bit too far, but no, I can't close in anymore. Close up. So yeah, okay. You just have to trust me. You probably won't be able to see it. But what we have here is we have a voltage divider on the voltage in, and the way the divider is configured is that the way it works is that if the voltage in through the divider goes under a threshold, then the whole chip just turns off, and there is a reset pin, a reset output pin, and a power good pin. And the reset, if the voltage in is under the threshold, the reset will be pulled down, so we know it is in reset state. And then the power good is if let's see, right, power good is if one of those is not enabled through the enable pin, it will also be down, which is a bit confusing. So this one will actually should be down when we start because the adjustable one will be off. But right now I have it configured to 11.3 volt, and what we get from the boost is 15, so it should pretty much always be good. If we fall under 12 volts from the 15 boost, then yeah, we are in trouble. Yeah, and as I mentioned, the enable for the adjustable, by default it's pulled down, which is off. And then the enable for the 3.3 volt is pulled high, so by default it's on. So that means the 3.3 should be there when we connect. And the 5 volt is also enabled. So that should also be on. Yes. Yep, correct. Let's see. That's kind of it. And there's test points for both of those. So we should be able to just see. Yeah, so I think we actually will connect and try it out and see what happens. Maybe I should first try to find, right, like I mentioned. Here you can see the 5 volt reference point or test point, so we can test it there. And the 3.3 is on this side, so that's, maybe I didn't think that's true. But I think we will power it in this way just so we can see if anything happens. Okay, I have the voltage in USB PD, I have it here. Let me also just get the multimeter. And yeah, you should be able to see it in the bottom left, small one. Oh, I thought the light would stay on, but it's only temporary. All right, so we can try it out. Very scary stuff. Let's see. It's not hot, so that's a great start. Maybe it's not on. Yeah, I think it is on. We can double check by measuring the 15 if the boost is working as expected. So here we have the 15 out, and we measure it. It is indeed 15, which you can't really see. No smoke, exactly, no smoke, so that's great. So we have the 15, and then, or we could actually test, let's go back, let's test the 3 volts. The moment of truth is here. So that's not right. 15 is 15, but 3.3 is something floating, so that's not great. Let's check the 5 volt then. Nothing is hot, so that's great. There's the 5 volt. Huh, so the 5 volt is 1.8. Interesting. Well, then we have to do some debugging. And then on the output here, there's actually 1.4 on the adjustable, which should be off, so that's also strange. 1.8. The 3 volt. 3 volt should actually be also on this side somewhere. No, it's on one of the headers. Yeah, it should be here. What did I choose? Because the voltage in is 15, so having it as 11 should be under the 12. Where is the power good? Then I did put test points for that. Are they on the top side? Or maybe I didn't put test paths for that. Let's see. Yeah, I guess I didn't. And the R26, that's the power good. Yeah, power good is put low because the enable pin for voltage 3 is also low, so that's expected to be low. But 27 is also low, and that's not good. That's expected to be high. Yeah, but then let's test. Let's see, pin 29 should be the voltage in. The voltage. Let's see. Right. So this is the 15 volt rail, and it is 15 volt, so that's good. Then on the voltage divider on pin 30, that's hard to find, but we can find the resistors. 24 and 25. Right, so here should be our, okay, why is 1.6? Oh, maybe that checks in actually, checks out. No, but I have a boost that boosts to 15 volts. So even the cheap power supply that will deliver 9 volt, it will get boosted to 15. So the back is always powered by the 15 from the boost, because you can also power it from USB from 5 volt, and then it gets boosted. So I'm trying to make it as flexible as possible. Right. I might need to open the datasheet. I want to see if the divider is within range. Right. To You're right, so the voltage divided threshold should be between 118 and 126, but we had more there, didn't we? Yeah, we had 1.66. That's too much. Did I screw up my math? Let's disconnect this. Because then it turns off also because it's out of range. The other way around. It's over. Let me just get, where is that? I'm just looking at the datasheet for the text that mentions the exact values that the divider should be between. Yeah, reset goes low if the voltage is below 123, but then it doesn't mention the other way around, except in the table. And the table mentions 126 max. Okay, so how did I screw this up? Let's see. I'm just rechecking my math. Actually, you know what I think? Because that was again the perfect. Right, why did I put this? Because 123 is the value that's exactly expected when the power is good. So why did I don't know why. I mean, this means the power will be good when the voltage is 1231. Because the actual threshold is 118, is that correct? Maybe. Or am I misunderstanding that? I'm just wondering what value can I substitute there? If we put 100k, then we should be closer to the expected value, but still probably out of range. Right, so if I put 122k instead of the 82, then I think we should have the proper threshold value. So let's try that. We remove this one. Wherever my tweezers are. There they are. Almost. There we go. Luckily I have the resistor book, so I can have whatever resistor I want. Ish. Yeah, 120k, that should do it. Am I winning? Maybe not exactly. We'll see. We will see if I'm winning after I replace this resistor here. Down these power planes. All right, so there's still a potential for magic smoke this time around. Where's the cable? Camera. It's a bit warm, so maybe that's good. Let's try again. Right, so here we have now 167, or no, 116, which actually might be too little now. Let's go back to the data sheet. Let's just test the voltage. Yeah. I think that's, I mean, yeah, that's under the 123 threshold. So, I guess these resistors are 10% or something because it's really off. Yeah, I do have needles at the hackerspace. These are not exactly great. Okay, so that's 120 is too high. I need to go, I guess, 100K. And we'll see how that goes. Yeah, I'm not being gentle with these resistors. I'm just rechecking the math because won't that give us maybe we will go over. Okay, it's 112 actually. Yeah, so 100 should put us where we want, hopefully. Yeah. So there's still potential for magic smoke when this threshold actually becomes proper. But that's really strange actually that we were getting still some voltages. I would assume it would cut off totally, but nope. It actually was doing stuff, just power good was not good. Okay. No smoke just yet. Okay, so you can't see. But now 3.3 is 4.3. So we're getting somewhere. 3.3 is 4.3. 147. What the heck? So that's still a bit too high. I don't think I have 100. We might have to wing it. Because here 110 would be best. I don't know. Oh no, I do have 110. Surely third time's the charm, right? Yeah, as long as there is no magic smoke, I can also keep going. Once the chip dies, we might not be so lucky. It's actually good I didn't put the other chips yet, because they expect 3.3 volt, and now the 3.3 rail was 4.3, so those chips might have been sad, so to speak. This is 110k, and the math tells me it should be 112, so hopefully we will be within the error range. Yeah, that works. Alright, third time is the charm. Yeah, 125, so we are in range. And 3.3 is now, whoa, that's very... Interesting. Yeah, something is very strange here. So you can't see... So this is the 5 volt rail. It is 480 millivolts. And the 3.3 is actually very jumpy. 2.6, 2.5, 2.4, 2.7. This is low and this is... Okay, so both are still low. So it's still in the reset state. Yeah. But now the threshold is 125, which I think is within range. Yeah, the threshold is 123 to 126. What is the problem now? Let's check. There's a 7 volt out regulator here. Do we get that 7 volt? Also, let's check one more time. Yeah, 15 volt, so that's good. Here we have 125, like on the dot. And then on this side, yeah, so that's actually, no, that's not where it should be. 6.24, which I think is in range for that one. Yeah, so this pin should maximum be 6.3 volts. And what was it? 624. So that's the internal LDO works. So that's something. this is within range, I would say, just enough. 15 is still 15. So why? An adjustable should be here. 1.3. So let's see, there is a mode pin which there's a pull up on that one. Because that pin defines exactly, if we pull mode high, then automatic power-up sequence is provided according to the states of enable pins. And I do pull it high. We can double check that. R23. Can flip it actually. There's R23. Yeah, so we it's pulled up, which means the power sequence is according to the enable pins. What if we pull that down? Where does that? Oh, actually, that might have to be pulled low. I misunderstand when I read this. Because the way the datasheet says is, if the mode pin is high, then the 3 bucks start up and shut down in sequence according to the enable pins. If it is low, the 3 bucks are controlled by 3 enable pins. So this, I think, actually should be low. Although, okay, so that should be low. It's high right now. But if it's high, then it just defines the sequence of starting. So they should still be on, unless... Let's see, enable 1 is low. Enable 2 is high. Now that one actually might have to go low. So let's fix that. Which one was it? 23. Okay, let's leave this here. That's not going anywhere. And then this is a ground pin, so we will just tie them together. Oh, you can't really see. This is a 65261. 65261, not 251. Yes, I took this resistor here and I put it up on one side, and then we can short that to the ground here. It's just a pull, so there doesn't need to be a beefy wire for it. Need more solder. Yeah, there's a lot of modes, but there is also the last one, which is low, low, reserved, and that's a reserved one. So maybe if we end up in that one, everything is screwed up somehow. Oh, sorry about that. Let's double check the continuity. Okay, so now it's pulled low. Still no smoke for now. Okay, so let's 15 volts, still there. Reference 125. This should be low. It is. So the 5 volt still not going. Whoa. So let's check the 5 volt enable R20 right there. Hmm. Is that pulled too high, too highly? Yeah, so this is supposed to be a 10k, it's like an 8 something k, that's right, I guess. But maybe the pull is too low to enable that one, because again, this is supposed to be 6.3. No, wrong mode. It is 6.3, so that's good. And then it should go here. And then here we are after the drop. That seems really, really low. But then what's the minimum voltage on the enable pins? Because maybe they are too low. Yeah, so the enable pin has to be at least 1.2 volt to be considered high, and now we have 0.7, so that's too, this pull is too high. But it's only 10k, is that? My math failing me right now. Let's change that pull as well then, because the way this is set up is that the 5 volt is enabled first, and then the 5 volt enables the 3 volts. So if the 5 volt is not working, then no others will work either. So if I put a 4.7k, I think that should be enough then to be 1.2 volts. Yeah, there was quite a lot of math that went into this, and clearly still not enough because I didn't quite get it to work on first try. So let's see the voltage now on that resistor. Till 15. Is it that there's something? I mean, I could tie it directly just high. That's an option. Because at that point, a pull-up of 1K doesn't really make sense. But I wonder if there's something shorting that pin down elsewhere, and that's why it's so low. Because if that happens, then this will short just plus to minus, and that's gonna blow some smoke. Yeah, let's try it. Yeah. See, there we go. So now 5 volt is 5.1. So that part works. And 3 is 4.5, so that's wrong. But we can check that one, because maybe that resistor is also too low now. Yeah, it's always awkward because, you know, on Twitter, it looks as if everything works on first try, but it's never like that. But you never see that really behind the scenes. So it's a bit awkward showing that it doesn't work perfect. But we have 5 volt now. And 5.1, I think that's expected. That's within range still for the math. So 5 volt, and that's okay that this is shorted, because I mean, it's not okay exactly, but I don't want to disable that one anyway ever. .5, that's a really strange value. Okay, but then let's switch to the next resistor and see if that one is high as it should be. And that is R18, which shouldn't be that far. And as I say that, there, so it's that one. Right. Yeah. Whoa, why? How can it be that this voltage is even higher? That doesn't add up. Something very strange. That means 3.3 should be good because it's definitely more than 1.2 on this side. 575, that is a lot. Hmm. .3, that's right. This was for the mode, yeah. Hmm. Let's see what else. So this is the pull up to enable the 3.3, and this is the pull down to by default disable the adjustable one. And this should be ground. It is. And on this side, okay, why is it 5 volt? That's really, I don't, because that means the adjustable is also enabled. This does not check out. Yeah, the JLC PCB does e-test, which means they test, or maybe they don't test shorts, but they do test continuity, that each pair of pads that should be connected is connected. I don't think they actually test for shorts. But yeah, I haven't really had ever a problem where something was shorted on the board, at least. What can we do? Let's double check again. The reset and the power is good, because that part, the reset should at least be high right now. Where was that? 27. Yeah, so something is still wrong, because the reset is low, and it should be, reset is only low if the voltage divider is out of range, I believe. Exactly. Reset is pulled low if the voltage divider is below 123. But the problem is the divider is 124. So why is this low? That's a question. Yeah, I'm a bit out of ideas right now. What else could it be? Yeah, that was outside some racing, street racing. Yeah, 124 is close to 123, but then uh, maybe. Yeah, I'm also wondering if I'm misunderstanding what it says here. Because the VDiff threshold is 118 to 126. So does that mean I have to be above 126 actually? Because then, of course, I'm not. Yeah, I guess we can try again with the 100K, because last time we tried that was before I changed the mode also. Right, my TS100 went to deep sleep. Yeah, there's a comparator inside according to their the block diagram that compares to 123. I guess there's no exact upper limit, like you say. Where did it go? Oh yeah, it's on my tweezers. Here it is. Can you turn on the light, please? Thanks. Yeah, exactly. Beyond 126. Yeah, that's what I thought. But then the 82K that I started with put it at way higher. Well, let's try now. So now we have 137, way above 126. And the 5 volt is 5.1 and 3.3 is 4.5. So nothing changed. And then was it 26? That was. See, so that's the really strange thing. Like now we have 137, so it's definitely above, and yet still the reset is still low. So what's up with that? This seems to be the main problem right now. There's one, or no. Yeah, it is pulled high, but it is pulled high to 3.3. So I wonder if it should be pulled high to 7.7 then, or the 6.3. But when you see on this, you can see on the pull side, it is actually 4.5. When was it? 27. Hi, Emre. Yeah, we soldered stuff and it doesn't quite work, so debugging is ongoing. And that one is destroyed. Does my multimeter have a low Z voltage measurement? I don't know. Don't think so. Bye, bully. Yeah, I'm not sure if the um, yes, I will try to pull it up now to the internal LDO. So let's see how that works out. So the reset is pulled up to the 6.3 from the LDO. Yep. Let's check. The 6.3 is still 6.3. But the pool is, yeah, reset is still low. Yeah. I don't get the problem. Seems unlikely that it got damaged. I was thinking if there's any shorts under, so we could reflow it again, just like poke it a bit so it jumps into place, but I don't think that would do anything. Usually it would get really hot if something was shorted under. And as long as we're testing the voltages and their in expected range, like the reset, then it should behave as expected, but clearly it doesn't. Let's see. I will try to pull up the 3D render in KiCad just to compare if, like, I put all the components in proper places, if resistors are, resistors and caps are caps, because maybe I screwed the assembly up and then there's a resistor instead of a cap somewhere, or the other way around. Yes, it does have a ground pad, and I did solder that there, so it should be fine. The nightly KiCad build I have is a bit slow. Okay, there we go. View, 3D view. So there's caps, there's resistors. Yep. The resistor. Yeah, so all that looks good actually. I mean, I can't confirm that the values are correct, but it should be fine. Yeah, so the 5 volt is still 5 volt as expected, but the 3.3 is 4.5. Did I screw up the... So I could have screwed up the resistors, but that also doesn't explain why the reset is still low. The power good, I can understand that it's low because the third buck is not enabled. At least it shouldn't be. It should be pulled down by R16, which is here. Except I think the issue we're seeing. Okay, so that is low, so that's good. That's expected at least. But then, where is it? R18 should be on the 5 volt. See, so that's another strange thing, because this is the 5 volt rail, and then it's an open drain, and there's a resistor. So how is it possible that the voltage on the other side of the resistor is actually higher if it's an open drain? That doesn't make sense. And for the 5 volt, where's the enable? R20, so that's the one that's the one we shorted. Or could it be that this also expects to be pulled to... Because maybe they all expect to be pulled to 6.3, but that's not what I thought when I read the data sheet. Or actually even... Yeah, I'm looking at the dev board, the reference dev board, and there the enable pins are actually pulled to voltage in, which in our case is 15 volt. So that's even more interesting. I mean, we could try that. Nothing to lose. So R20, correct? No, R18. Or if we connect it first to the 7 volt. Double check. Okay, they can float to be high, right? So if I leave it like this right now, which is not connected to anything, R18, yeah. What will we get? That's the wrong way around, but that doesn't matter. So the 5 volt. Wow, that doesn't even make sense now. So right now the 3.3 is all around the place, and 5 also broke, even though 5 is still tied. Oh wow. Okay, so right now the internal LDO is also just going crazy. Okay, so now even the 15 was broken, so something broke quite badly there. Let's try that again. Okay, so 15 is still 15. And then five is trash. 3 is still 4.5. That doesn't. What the hell? Okay, so that doesn't make sense. I disconnected the enable pin from the 3 volt, and the 3 volt is still on, but the 5 volt is off. What? Did I screw up the pins? No. Oh. No, doesn't. Yeah, mode is pulled. It's low over a 10k resistor. Hmm. Yeah. Looks like we're on 3 hours of stream now. But yeah, we can keep going. Not much other to do. I have to get this to work before I can continue. So you can join me on this debugging quest. Maybe it's not the most interesting thing, but we'll see. Now everything is strange because even the 15 volt is not as expected. Yeah, right now the 15 volt is not 15 volt. Right, the button has to be up. Did that get pressed at some point or what happened? This is quite strange also because if enable have internal pool, then shouldn't they be something? Because right now it's like perfect zero. I don't think it damaged it. Especially since I only set it to reflow like the solder, and then I moved it away when I put the chip on. Also, I don't believe it to be really 440. I mean, I set it to that much, but I don't think it's that high. I don't think I ever had that happen, like chip damaged by heat. At least I don't think so. I'm sure I could put another one, but wouldn't expect that to help. There's many strange things because, okay, so this is the enable for the 5 volt. There's nothing there, which means it's floating, and floating means it's on. When I test the 5 volt, I get 1.1 crap. Next thing is this is the enable for the adjustable voltage, and it's pulled low, which means it should be off. But when I test it, there's actually a 1.3 on it. So the enable pins are just not, like, they don't work as as I expect them to. But maybe like we're getting ahead of ourselves, because if the reset is low, then maybe you can't trust anything. But the reset is supposed to only depend on on the divider, and the divider is 138, which is supposed to be good. I mean, VN, what is the range for VN? I'm fairly sure. $15 is okay. Yeah. So VN is up to 20 volts. So it's not like I'm sending it more voltage than it's allowing. So that part is fine. And even if my feedback capacitor or resistors are wrong, that's still, I don't think that would cause the reset to be kept low. That's the biggest mystery right now for me. And the internal LDO works because we get the 6.3 as expected. So some of it works. And that's like the worst. Because if nothing worked, at least we would have something. I'm a bit going in circles here. That's low. Yeah, low. Like, yeah. I mean, there's so many things that could be wrong. Like maybe the resistor that sets the frequency is wrong, but would that matter to the reset circuitry? It doesn't seem so, because on the block diagram, it's only the voltage in and the reset. The reset is just connected to a comparator with 123 reference. That's it. Okay, let's try some math again. That's from the, like, if you're following with the data sheet, I'm gonna do equations 2 and 3 on page 15, which are the thresholds for the V in. And right now, what did I put there? 100K, right? Yeah. Prop the VDiv on the IC. Sure, I can try that also. I have a second multimeter probe here, and I'm trying to see, are those? No, it's pretty much the same. But I should. Yeah. I have this guy, which is a needle point probe, so that should be way smaller to poke things. So that we can do. Jeez. Sorry about that. I'm just gonna make sure I don't have to hold the ground. Just clip it here. Can't really clip it because then I cannot access it. Or I can't lay it flat. Actually, I can do this. Yeah. It makes contact on the bottom, so that works. If we zoom in real, there. Right, so this is this one. We have 148, and that just goes here. Yeah, 137. I mean, when we look at the solder, it looks good. Like nothing seems shorted. But yeah, let's try that. Let's try some nice math then. So the threshold that it has to, V in has to, the threshold R, if you're following with the data sheet, is the threshold that it has to cross to be a good power, and that is 123 volts, the Vref, times 1 plus, and then R1, which is 100K divided by 10K minus 1 microamp times 100K. That's correct. That seems to be correct. And then I plug that into Wolfram alpha. And yeah, so we get 13.43. So once the voltage in hits 13.43, then it's assumed to be good. So if we check the other one, because that's the lower limit, and if that one is too low, then we would still be assumed wrong. And there's only one difference here. It's 2 microamps instead of 1. Okay. But then that doesn't add up. Maybe that resistor has to be even higher. If it's 150 kilo. Yeah. I do have an oscilloscope. Do you think, yeah, you want to measure if VN oscillates? I'm thinking it comes from a DC-DC, it will oscillate. Hmm. Yeah, so I'm doing the calculations here, and it seems if I put 110k, then the threshold that the voltage has to be it has to be more than 14.5. No, it has to be more than 14.6, and then it goes off if it goes under 14.5. So that actually would be okay, but now it's 100k. No, let's just still work with the value we have right now. Yeah, I can have a look at the 15 volt under a oscilloscope. That should do it. Yeah, but those calculations show the voltage levels. But yeah, according to them, it still should work, and it is, according to the multimeter above. But if the DC-DC is keeping it on off, then yeah. There we go. Thanks, Mr. Who. Thanks for stopping by, and see you around. Let me try something. That is not exactly perfect. Can I rotate this somehow? I can't really rotate this. I guess it's something. As long as it's not on the big screen, then maybe it's all right. Oh. Oh. This one working? It is. Okay. All right, so we're connected, so we can measure the voltage in. Yeah, so the 15, okay, dropped a bit there. I mean, this is now 1 second per division. Is it? It seems pretty stable. It's not showing frequency because I guess it's stable enough. Yeah, so that 3, so the 15 volts seems really, really stable. Oh. It's peak to peak 88 millivolts, so that seems fairly okay. If we switch to DC, and then on the VDIF, oh, actually the voltage should be. Yeah, so this is VDIV. No problem. It looks super stable, and it's max it's minimum. I mean, still within range, but yeah, then it's 10 millivolts. So that's pretty damn stable. Oh, hey, yo. So this is, oh, nice. This is the internal LDO. Oops. Yeah, but it's still in acceptable range, I would say. Yeah. Mm. So this is, yeah, let's start with 5. Whoa, this is 5 volt. That's quite a mess there. Yeah, that's not good. Minus 7.6 up to max 23. That's really bad. But then why? No, the internal LDO, this is it. So that's really stable. But then the 5 volt, it's really bad. 3.3, also not good at all. It's peak to peak. Yeah, 7 volt peak to peak on the 3 volt, even though the, or no, 3 volt should be on. And this is the adjustable. So it's stable, but it's at 1.2 and it should be at 0 totally. So even that part is not working as expected. Yeah, the schematic, I compared it to the reference board, and it seemed correct. So now I'm looking, this is the VDIV, minimum 1.2, and that's too little, maximum 1.6. So peak to peak is 400. That's pretty big peak to peak on this one, and that means minimum goes under. So maybe we should actually put even higher value there, because yeah, there's a peak to peak 800 millivolt on the 15 volt, so it goes 14.8 to 15.6. So that would explain why the VDIV also jumps a bit. So actually, let's change it yet again. Or did I? No. Okay. If I plug the yeah, exactly. Maybe I should just crank it up. Yeah, because I'm just checking what value I should put in there. The original 82K should be way within the limits. Yeah, there it is. I mean, it didn't work with 82K, but that was because before we changed some other stuff, some other resistors, so maybe. Right, so we have this. I can measure the VDIV now. it's 1.6. That's really high. And then the LDO is 6.2. That's still good. But reset is still low. And 5 volt is 1.9, 1.4. 3 volt is 4.5. Adjustable is 1.4. So that's a fail. If I look at my schematic, compare it to the reference, can I see anything? Yeah, I see the viewers are dropping off, and I don't blame you. Quite the fail all around. But nothing that I can see that's different, really. Yeah, that might just that might have to be it. That I just do the basics, the most basic stuff, and then bypass the 15 volt in like this. I mean, we could try just providing 15 volt from a power supply anyway. Yeah, so I set my power supply to 15 volt and can connect the ground here. And we can solder a wire to connect the 15 volt in. Oh, come on. I guess even troubleshooting can have a value, but only if it actually ends with fixing the issue. Right now, it's not quite there. Right, so we have the ground here, then here there's the 15 volt. I'm gonna connect that to 15 volt in from power supply. I'm gonna lower the current for now. It actually claims 0 current, but it's not very granular, so it's probably very low current. Where's the button? So let's start with normal. So 15 volt, correct. Then here on the LDO 624. One of these. Nope, no power good, no. Yeah, 1.6 on the V divider. And then this is 3.3. Crazy number. And 5. Crazy number. Yeah, so that doesn't seem to be. So the DC boost doesn't seem to be the issue, because we saw on the microscope it's pretty stable, surprisingly stable. And then yeah, the power supply. They are going to, yeah, you mean these vias here. These are going to the SAMD, so I could read if power is good and if the reset is on. in theory from the SAMD, even though if the power is not good, then the SAMD is not running. But that's a detail. But right now the SAMD is not soldered, so they're going nowhere. They're going to a pad, so that shouldn't matter. And the pull-ups, yeah, those are also on the reference board. So since they're open drain, so that should be fine. So yeah, we're closing in on midnight on 4 hours of streaming. Any last minute ideas? Otherwise, I think I will admit defeat for today and close the stream at like midnight. Maybe not all of them are perfectly soldered, but they are connected. So it shouldn't be a problem. Yeah, see you, Gerald. Thanks for stopping by. I'm glad you learned something. Yeah, I could remove the components for the other bugs, but I mean the enable is pulled low, so it should be off, even though it's not off. So that's annoying. That's an annoying thing. Wow, that came off easier than I expected, actually. So let's leave the 5 volt on, but let's remove the 3.3 also. And then, okay, so let's explicitly turn these off, even though they're missing now. So let's see. So R16, right, so that one is the disable, or is the enable for the adjustable, and that's put low, so that should be off. And then the 3.3 is on R18, right, the one that's in the error. And that's right. So this is the pin that goes to the DC-DC. And then we can short it to ground, which this is ground. Yeah, I thought about shorting them, but since they have some internal logic for floating, then I don't trust them, so I just pull them down. I also have one more idea to actually pull mode just directly to ground, because right now it's through the pool, and maybe it's not happy about that for some reason. So I will do that as well. Okay, that should do it. So, all right. Okay, so let's start from beginning. 15 volt is 15 volt. VDEV is 1.6. Mode is this one. Is it? Yeah, this is ground and it's pulled to ground. Mode is, yeah, like pretty much 0. So it should be fine. And then let's see, so 3.3 enable is 0 and adjustable also 0. Interesting, because before that was total chaos. And now 3.3 is 0, adjustable is 0, so enable, so 5 volt is 1.5. It was going well until it stopped going well. Yep, and still reset, even though it's pulled high. 6.2. Reset is still low. This is the 5 volt, 5 volt enable, isn't it? This one. Yeah, R20. Yeah, so it's floating, so it should be enabled by default. It is not. So yeah, something is screwed. Hmm. Yeah, I think that I will have to assemble one more just to verify, because maybe it refilled badly. To be honest, we could, again, as a last thing, I can just hot air it again and poke it a bit in place. If it's off, not soldered properly, it might jump into place. Just flux it to hell. There you go. Yep. Do you see that? It moved nicely into place. That was a nice shift. You can double check all the pins, because some of them look a bit under soldered now. That's alright. Hey, sorry. That's alright. Yeah, that one looks, the third one from the left looks a bit under soldered. Wow, I scratched this a lot. I was using the probe to get ground there. Okay, that looks good. So there's only that one. We can try to fix that. Alright. Which cup was not soldered? Sorry. Oof, what a mess. C31. Right, but that shouldn't. I was gonna say it should matter, but I'm not sure that's right. More flax. Can we get more light? Nope. They are way too happy to stay together. That is nasty. I'm not gonna lie. So let's clean it up and reapply flux. Yeah, just like new. And then we drum it in flux again, wherever I put the flux. And okay, I think that's good enough. Yeah, I know there's no flux. I just want to touch it up. That looks good enough. So after all this, last chance. Would be nice to end on a high note. Come on. 4 freaking hours. Okay, 15 volt is 15 volt. Let's see 31. Okay, just a moment. Huh. 165. Oh. Okay. I mean, it's not great, but it is reflowed. It's a bit cold. And this side looks, yeah. To be honest, the 31 doesn't matter right now because this is the power, this is the voltage in for this, for the 3 volts. This one is the voltage in decoupling for the 5 volt. So that one doesn't matter so much right now. Unfortunately, I wish it was this simple. That's not good, but I guess it doesn't matter since there's no data coming in anyway. But maybe let's do it like this. Fifteen is 15. VDiv is 165, way above 123. And yet the power good and reset are low. And 5 volt is crap. At least the 3 volt. And the V-adjust, shut up now. And the camera is way more, it goes out of focus way easier than what I see actually through the optics. So even if I tie the enable to 6 volt, I still get crap. Yeah. If I double check the resistors for the 5 volt, they should be 10K. That's a pretty good 10K, and 73.2. Is that correct? That's not correct. 32, 33. Is that one wrong? It should be 73.2, but it is 450. And now measuring resistance in, no, 73.2. Damn. Measuring resistance in circuit is strange, especially with the auto. I feel like they get strange things happen. This was 10K before. Range. Why is this not 5? It was. Yep, 10 and 73. Yeah, so they are correct. I mean, even if they were not correct, the reset, why is the reset down? Think. It should always be 0.6 if it's working correctly. Guess that's true. I'm fairly sure it's not working correctly. Yeah, oh, you can't see, can you? I believe this is the feedback, because you can see the 5 volt goes here. You can't see really. Now you can kind of see the 5 volt goes here into this resistor, and then there's the divider, so the feedback is there, and this is all ground, I believe. Yeah, so this should be the feedback, which is 200 milli as opposed to 600, so that's clearly wrong as well. So the back might be wrong. Yeah. So I think that's it for today. And we crossed midnight, so that's it for today twice. Yeah, we checked some stuff. None of it helped. I will, I guess, assemble another board and see how that goes. I always look tired. But also I've been streaming 4 hours, so maybe. Just trying to think some last minute, but I don't think we will get anything. I guess I have to figure out the minimum components that it should still work. Thanks. Yep, and that's it. So thanks for watching, thanks for hanging out. The 9 of you that survived the whole thing, thanks for your help. And yeah, keep an eye on my Twitter. I will announce another stream at some point next week, I'm guessing, because YouTube notifications suck, so you might miss it otherwise. Yeah, I have some dark drink here. Yeah, thanks for watching, and good night or have a nice day, depending on which time zone you are. See you.